Hello everyone, I'm Yu Jian. Let me introduce our paper, a review of cross-domain text-to-SQL models. Our paper focuses on the text-to-SQL problem. But what is text-to-SQL? Text-to-SQL is a task to translate the natural language query written by human into the SQL query automatically. Here is an example. A human without database knowledge write a natural language question. What are the names of French singer? The text-to-SQL task is to translate this question into a SQL query, which is select name from singer table where country column equal to France. Our paper reviews the top models in the two cross-domain text-to-SQL leaderboards, which is WikiSQL and Spider. We first divide these models into two paradigms. We then present the key module details, while some of the details are not mentioned in their original papers. WikiSQL and Spider are all cross-domain text-to-SQL datasets, but the SQL queries and database structure in the Spider are more complicated than that in WikiSQL. These two benchmarks all provide a leaderboard to illustrate the performance of different models. In the beginning of our paper, we divide these models into two paradigms. Every paradigm contains a two-step process toward text-to-SQL. Here we are showing the first paradigm. In this paradigm, models will generate the SQL structure first, and then fill the schema items into the SQL structure. For example, we first generate the blue SQL structure from the natural language question, and then fill the schema items into the SQL structure. The schema items here are the MPG and cast data and also the cylinder. In the second paradigm, its first step is to generate a label to every word token of the question. Here I use a yellow pen to draw your attention to the labels generated by the models belonging to the paradigm 2. After the first step, the model can generate a SQL from the label deterministically. There are problems in both paradigms. The problem in paradigm 1 is that separating the generation process of SQL structure and schema item will cause the same question token to be used repeatedly. For example, in here, paradigm 1 will use the word average twice in both generating the SQL structure and schema item, which means it will generate the AVG aggregation function for the SQL structure and also choose the average column as a correct column. We can find many these types of wrong prediction from the model belonging to paradigm 1. As to paradigm 2, this paradigm is now only used by the models in the WikiSQL benchmark, because generating the correct annotation for Spider benchmark requires much more work than for WikiSQL, since the sentence and SQL queries in Spider are much more complicated than that in the WikiSQL. Although there are only two paradigms, their model implementation details are different. For example, some people use transformer while others use the LSTM. No matter what implementation details are used, the current top models are all follow these two paradigms. In these models, we find out four key modules that affect the performance mostly. The first module are their decoder. However, due to the page limitation and their decoders are almost the same in the top models, so we didn't discuss it in our paper. We focus on the rest three key modules in our paper. The first key module is Schema Linking. Schema Linking is a key module used by all the models in these two paradigms. It helps fill the schema items in paradigm 1, so Schema Linking works in the second step of paradigm 1. Schema Linking also helps generate the COL and table labels in paradigm 2, so the accuracy of Schema Linking determines whether we could choose the correct schema item from the database. There are several methods to construct the schema linking. You can find details from our paper and the reference. Now we would like to introduce why picture-word embeddings can improve the schema linking. We give an example here. Without a picture-word embeddings, it is hard to construct a link from the word French to the country column. Picture-word embeddings also improve the accuracy of SQL structure generation. The further discussion in picture-word embedding can be found from our paper. In the end of the paper, we list three ideas for the future work in this area. One of them are combining both paradigms to generate SQL. For example, we can generate the labels for the question and then train a neural text-to-SQL model using both the question and the labels. We expect the annotation for the word average is COL, not AVG here. The SQL structure generation process may not generate the average function since there is no AVG label. For other details and future directions, you can find them from our paper. Thank you for listening.